Okay. So we were on 7.3 shell method. So let's do a few more. Continue. Okay. The use shell method. To find the volume of the solid formed by revolving the region bounded by the I guess here are the functions. Y equals x squared plus 1. Y equals 0. We haven't done this one, right? No, I don't think so. X equals 0. X equal 1. And we're going to rotate about y-axis. All right. So here are the
Hello?
yeah.
Were we not having class at school today?
It's up to you. I'm here in class. You can come to class or you can do Zoom. It's up to you.
119, right?
Yeah, 119 science building.
It looked busy. Let me double check again.
It looked what?
It looked busy. I'm gonna go double check again.
Yeah, when we're in here, so we are busy.
I probably did look like at the wrong one, my bad.
There should be only 3 people in here.
Okay. Thank you.
All right. Okay. Let's see, where were we? So let's graph this region.
Well, what if people were running late or just not showing up? If you don't mind my inquiry,
What's up?
are people late or just not showing up? We used to have a class of over 8 on Zoom.
Yeah, class starts at 8:10.
No,
Technically.
so we used to have over 8 participants on Zoom, but according to my the count, that sounds like we only have like 5 people.
Yeah, there's a couple people that are absent.
Okay, that's what I was saying. So something that didn't sound right with that.
Yeah, so yeah, they're just not here today.
Okay, I was just wondering. Hell, I'm actually currently still working, and I'm at least we're listening to the lecture.
Gotcha. It's
So
all
it's
good.
like, whew.
Hey, you go to the wrong room or what? Oh. It's all good. All right, let's get back to it. Okay, so so this is one of the bounds. So I'm going to put 1 right here. Zero, well, that's of course over here, the y-axis. So that's the next other bound. The parabola 0 would be right here. So let's say this is the 1 point of the parabola. If I plug in 1, I would get 2. So that would be over here based on the axes that I'm using. That's what it would look like. So the region that we care about is in here, because y = 0 would be the x-axis. So I'm looking for this area. All right, so they said rotating about the y-axis. So I'm rotating this way. So if I'm rotating on the y, and they told me to use shell, that means the slice has to be parallel, the rectangles, to the rotational axis, right? Okay. So now we need h, the height, h of x. That's going to be the top, x squared plus 1 minus 0. Now rho, that depends where the axis is, right? So we said if it's to the right, it's going to be either a minus x or x minus a. So let's look at our notes at the very beginning. It's 3.7.3. We said if the region is to the right, and it is, right? So we're going to do x minus a, where a is the rotation axis. So x minus 0. So the shell method, the volume will be equal to 2 pi integral of height. I'm going to go ahead and write the formula. H of x times rho of x dx from some a to b. So 2 pi would be multiplied on, so the bounds would be what? What are the bounds? 0 to 1 here, right? 0 to 1. That's just a random dot there. This is 0 over here. Okay. So height times x times dx. So that would be pretty straightforward, right? That would be x cubed plus x 0 to 1. Any questions on the setup? So at that point, our answer would be x to the 4th over 4 plus x squared over 2 from 0 to 1, which would be 2 pi times 1/4 plus 1/2 minus 0. So our answer would be what? 1/4 plus 1/2. 3/4 times 2. Be 3 pi halves, right? Any question on this problem? All right, let's do another one. All right, let's go to the next question. This time, let's do the same problem doing disk and shell. See the difference. So on your exam, you have a question like this. Well, I'm just going to tell you, find the volume. You decide what you want to do. Find the volume of the solid formed by revolving the region formed by the following. Let's see here. I didn't write the equation. That's weird. One second. Y equals 1 plus x minus 2 root x. X equals 0. Y equals 0. So this is part A about, yeah, you know, in this, let's just do different types of rotations and we will choose what method to use. That'll be up to us. The x-axis, B, the y-axis, C, the line y equals 1. So we have 3 different questions because we're going to be revolving this region here, here, and here. Okay. And to make it a little easier, I'm going to give you the graph. So for part A, right? Let me just go ahead and give you the graph first. So here's 1. Here's 1. The graph looks something like this. Let me zoom in at this point. So it's bounded here, bounded here, and bounded there. So I want to know this area. So if I'm rotating about the x-axis this way, what method would be easier, shell, disk, or washer?
Should be a disk, right?
Because if I do disks, then that would have to be perpendicular, which would let me use dx, right? Since everything is solved for y, we want to use dx. Otherwise, we would have to solve for x, and it doesn't look like we could implicitly. So we want to stick with dx. So if I'm revolving this way for part A, that means that I want to slice this way, right? Which allows me to do dx. But the rules say that if I'm going to slice perpendicular to the rotation, I must use disk. So the formula for disk is pi times the radius squared dx. Do I have an inner hole? Do I need washer, or is disk fine? Because I'm right on there, right? So I'm spinning like this. So we're good. Okay. So now what is R? Yeah, it's from the top of the edge of the region all the way down to the rotation axis, which is 0. Yeah. Okay, so that shouldn't be too bad, right? The integral of 1 plus x minus 2 root x squared, though. So if I square that, it's gonna look really crappy. Oh, well. Just to make myself, make this a little easier in my imagination. Write it this way. So 1 times all these things. So the first pieces will be 1. I'm gonna put parentheses so I know that I multiplied the first piece. Plus then x times everything, that'll be x plus x squared minus 2x to the 3 halves. Plus. So this one came from doing 1 times all this stuff. This came from doing x times all this stuff. Now I'm doing -2 root x times all of these. So I'm multiplying everything out, okay? Trying to do it as easy as possible. As neat as possible, because easily make a mistake here. Okay, so I have only one constant, right? The 1. So I'll just write the 1 down. I have an x, 4x. Is that it? Oh wait, 2. X plus x plus 4, so 6. So I'm gonna cross those out. Now x squared, is that the only one? Yeah. Okay. Anything with a root, so -2 root minus 2 root, so that would be -4 root x, right? Okay. -2, -2, that'll be -4x 3 halves. All right. We're just doing some algebra. Now we gotta integrate. And of course the bounds are 0 to 1, right? The integral of 1 was x. Integral of 6x is 3x squared plus x cubed over 3 minus 8x to the 3/2 minus, what's that gonna be? If I add 1, that's 5/2, right? So 8/5 x to the 3/2. Feel free to check my mental math there. That look right? Let's see. If I add 1, that's 3/2 divided by 3/2. This one's off. It should be over 3. 3/2 plus 1 should be 5/2. Forgot the 5. 5/2 divided into 4 would be 8/5. 3, 2. Looks good to me. What do you guys think?
Yeah.
Okay. Plug in the 1 minus 0. So the 0 doesn't do anything. It's just the 1. So the answer will be pi times 1 plus 3 plus 1/3 minus 8/3 minus 8/5, which is something 5/15. I'm skipping the numbers because that's we've done that lots of times already. The part I need you to see is the setup. Does this make sense how we set it up? Do you see why we chose disk instead of shell? You see how shell would have been either impossible or incredibly difficult. If we did shell, you would have to solve for x here. Can you solve for x? Write this down. Yeah, you get x by itself. I can x out. I get 1 minus 2. No, it's not that. So a shell looks like it would be impossible. So you have to do disk for this part. This for part A. Any question on part A? I'm gonna start B now. Yes. Part B. It's the same question about the y-axis. So same graph. So 1, 1, doing this thing here. Not necessarily. They're doing rotation about the y, right? So if I choose to do disk, I would have to be perpendicular and go this way, which would be dy. So I run into the same problem, right? I can't solve for y or for x straight up because it's equal. The y function is equal to this. You cannot solve for x. It's not going to happen. You cannot get x on one side. So I have to do shell so I can slice parallel to the rotation, which will allow me to do dx, right? So now I just need the height and the row. The height is going to be the top minus the bottom, minus 0. The row, if I'm on the right side of the axis, then it's going to be x minus the axis, right? So the volume will be 2 pi height times rho dx. Which is equal to 2 pi times the integral from 0 to 1 of 1 plus x minus 2 root x times x. Distribute the x, you'll get this. Sorry, spaced out. So integrate, I don't have to write the symbol anymore, my bad. So that will be x squared over 2 plus x cubed over 3 minus what? 3 halves plus 1 is 5 halves, right? 2 divided by 5 halves is 4/5. Correct? Okay. I keep putting 3 when it's supposed to be 5. Okay. So just plug in the 1 and we're good. That'll be 1/2 plus 1/3 minus 4/5 minus 0, which is something. Yeah. So it turns out to have the same volume, right? if I spin this way versus spin the other way, solid in this case is the same. That's probably because of symmetry, not because that's supposed to happen all the time. Okay, don't think that's supposed to happen. Any questions on part B? Use the main, again, the main thing is a setup. Do you see how we pick the H in row and how we set it up here? If you understand that, then you get like 90% of the section. Because the rest is just integration like we've been doing since the beginning. Yeah, you gotta be able to figure out how do you get the H, how do you get the row. And the H is always the top of the shell, the top of the slice, the bottom. Row depends on where the region is relative to rotation. Yeah. So part C, the region is probably going to be to the left, so things are going to change. So let's do C. Everyone cool on B? No rush here. Oops. Oh, like he's freezing up on me. Strange. All right, part C. So it was about lexical one. Let's see. Yeah, I should have been X equals 1, but I might have written the wrong thing.
Put Y equals 1.
Yeah, it should have been X, so change it to X. So I want the region to be a specific spot. You can see the difference. Okay. Still the same graph, same region. I don't know, this volume rotated around this line. So I'm spinning this way now. Okay, I'm not spinning around here or down there, it's over here. Well, if we were to do disk, it would have to be perpendicular, which would cause problems, right? Because we'd have to solve for X again. So we can't use disk in this case because of the orientation of the rotation. Was it 1 plus X, right? Okay. So I'm going to do shell again so I can stick with DX. So H does not change, does it? Right, the height's still the same. Excuse me. The row changes. Remember we said if it's to the left, it's going to be the axis minus the region. Minus x, right? This will be 1 minus x. If the region was on this side and we're rotating on the 0, it would be 0 minus x. So it would be still be a negative x. So it depends on where the rotation is happening. Okay. So either go to 2 pi from a to b of h times rho dx. So 2 pi times the integral is still the same, 0 to 1, because it's dx. 1 plus x minus 2 root x times 1 minus x dx. So multiply that out, we're going to get 1 minus x plus x minus x squared plus a negative 2 root x plus 2x to the 3 halves. So that is a multiplication. Combine like terms. So there's only one. Negative x minus x is 0, right? So these are gone. Negative x squared is the only one. Negative 2 root x plus that guy. Okay. So there's the algebra. So now let's integrate. So this will be x minus x to the third over 3. Divide that by 3 halves. That'll be 4 thirds x to the 3 halves, right? Plus 1 is 5 halves. 4 fifths x to the 5 halves. So the answer will be 2 pi times 1 minus a third minus 4 thirds plus 4 fifths. Which is it the same volume? All right.
No.
Close, kind of. Gonna be the 4. Yeah, 4 pi 15. Yeah. Any questions on part C? Okay. Feel like we beat shell method to death, but I'm hoping it's starting to make sense. But I know when I first did it, that section was my least favorite. It just was really weird to visualize. It took me a long time. I think I honestly effed up that exam on that section. I preferred the series and sequences, which is the last chapter, one of the last chapters. But everybody else hates that chapter, so you'll probably disagree with me. All right, that's it for 7.3. Out of paper, so let's move into. 7.4 is pretty chill compared to this stuff. I think you'll like 7.4. It's easy, honest. Relatively easy.
What's the title of 7.4?
Arc length. Okay. So the first thing you're going to need is or I guess a reminder, the distance formula. For 2 points. X1, Y1, and X2, Y2. So the distance formula is D equal to square root. It should be very familiar. X2 minus X1 squared plus Y2 minus Y1 squared. Definition of arc length, which is the main thing of the section. So let the function y equal f of x represent a smooth curve on the interval a to b. The arc length of f between A and B is the following. So we'll call it, I think the book calls it S. S is equal to the integral from A to B of the square root of 1 plus f prime of x squared. So the derivative squared, 1 plus derivative squared dx. So it's all inside the root. And if it's a y base, if it's a y function like g of y, and then this is dy. But I think that's self-explanatory. We're not going to write that. Let me see if I can find a. Oh, let me see if I can find it. One moment. I'll show you guys a picture, but this thing is really slow, so give me a second. See if it lets me share. I think I might pick a new classroom next time. This computer sucks. My other class was in the engineering room. That one's way better, way faster. They have mics too, like, coming down. It's pretty cool. Yeah, it's just upstairs. So I want to see if anybody's in there. If not, if there isn't, I'm going to move to 201. But we'll see. So I'll let you know. Yeah, it's top floor, other side of the hallway. I'm sick of trying to share stuff, and it takes like 30 seconds or something. The classroom is the same. They just put new computers. So. Okay, so basically the idea of why that formula is 1 plus a derivative squared. So what they do is they take an infinite number of points. So pretend we had an infinite number of distant formula. You just keep doing it over and over again. You sum up every single point to infinity, and eventually you get the total sum of the curve, the length of the curve. So that's what they're doing here. So the theory and math behind it is they're taking the old school distance formula and adding an infinite number of pieces. And eventually you prove that it turns out to turn into this. When you take the limit of the sums of all these little pieces, you get this formula. So I'm not gonna prove this to you just to save time, but that's the idea. Okay. The proof might takes like 45 minutes. But anyway, long story short, you end up with this formula, which is really easy to use using math limits and some cool theory. Let's find an example. I don't think you'll need too many. It's pretty easy. As long as you can do algebra, this section will be simple. Relatively simple. Find the arc length of the graph of y minus 1 cubed equal to x squared on the interval. So you have to pick a location section. You can't just, find the total, right? Because otherwise that'd be infinite because it goes forever. So it has to be on some interval, 0 to 8. Round to 3 decimal places. Okay, 3 decimal places. So we have to solve for y in order to get it into this form, right? F and F prime. So the algebra will be the first part. We have to cube root both sides to solve for y. So cube root of both sides. Okay. So this is like my f. Okay. So the derivative. So f of x is this guy. What is the derivative? Oops, there's no 1. Right? So I'll use your formula. So we're going to integrate. So the arc length will be the integral from 0 to 8 of the square root of 1 plus the derivative squared. I think I need another page here. Wait a second. I'm going to turn the page. So I'm gonna have to, so the idea when you try to do these is you want to count to the square roots, unless there's some fancy substitution that you see. But about 80% of the time, you're just trying to get rid of the radical so you can integrate straight up. So what I'm gonna do is just work with the inside for a while. We'll get back to the integral in a second. So we know that if it's a perfect square, it'll cancel, right? So we may need to complete the square like the old days. It's just it's not gonna be, it's not a pretty binomial. So we'll get back to the integral. So right now we have, what is it? The derivative squared equal to, or f prime, I should say. Stay consistent. F prime of x. If we squared it, we were going to get 4/9, right? X to the negative 2/3. Yeah. So technically we have what? F prime plus 1 inside, right? The radical. So let's try to complete the square here and make it pretty, to the best of our ability. Just deal with the negative. So that's going to be 4/9x to the 2/3 plus 1. So now I need to get the same denominator and multiply the top and bottom by x to the 2/3. That would get me 9x to the 2/3 plus 9x to the 2/3. Now we can add them together. So that'll be 4 plus 9x to the 2/3 over 9x to the 2/3. The bottom part can now get out of the root, but not the top. Is that enough? Maybe we could do a, yeah, we could do a U sub. So let's get back to the integral now. It was 0 to 8, right? So right now we have all this nonsense. What is the square root of 9x to the 2/3? Or the goal is to cancel the root or use a U sub. Right. Square root of 9 is 3, right? Square root of 2/3 would be 1/3 because you'd cancel the 2. So we're going to get 1/3x to the 1/3. I'm going to pull that out of the root. Does that make sense? Now we can do a U sub because we have this on the outside. I was trying to see if I could complete the square and cancel it, but it doesn't look like it was going to happen because we had this denominator. But once I saw that I can square root the denominator, I said, okay, well, if it's outside, maybe we can do a U sub. So let U equal this nonsense. Du would be what? So it'd be 6x to the, right? Yeah. To the negative third. Dx. So du would be equal to 6 over x to the 1/3. It's pretty close, right? So we just need a third down there and get rid of that 6. Multiply by a third. First, let's get rid of the 6, right? So you agree that du over 6 will get me here, right? Now divide by 3 both sides, you're going to get du over 18 equal to dx over 3x 1/3. So now I can replace this and this with du over 18. So we get the integral of 0 to 8 of square root of u du over 18. So this one just turned out to be a little weird, but most of the time all you're doing is just trying to get rid of trying to set up the integral, make it easy. So I first had to combine the fraction, the inner part, and then do a u sub. That's all we did. So this will be 1 over 18 u to the 1/2 du. So that'll be 118 plus 1 will be 3/2. Divide by 3/2, that's 2/3. U to the 3/2. Change it back to x. That will be these cancel to 9. 9 times 3 is 27, right? Guess I picked the hard one. I'm sorry. I wanted to pick a medium one, but that didn't work out. Okay, the original u was 4 plus 9. Yeah, 0 to 8. Anyway, does the idea make sense? How you set these up? Let me find another one that's a little more straight up.
So that's the final answer.
No, you have to plug in the numbers and you're gonna get a decimal.
The balance.
Yeah, the final answer is like 9 point something. Like that. Okay, this is another one that has trig function, which is a little easier because when you have trig and squares or square roots, you can do some trig identities. Here we have to do some weirdo algebra. That's the life cycle. Guys, still on that page or you okay on that page?
No.
Okay.
I'll capture it when I review it.
Okay. Find the arc length of y equals ln cosine x from 0 to pi over 4. So the first thing that I need is the derivative. What is derivative of ln cosine?
Sine, and it's not.
It's a chain rule, right? So it'd be 1 over cosine times derivative of cosine, which is negative sine. Yeah. There. Then we need to square it, right, for the formula. Okay, so now we start the problem. Integral from 0 to pi over 4 of the square root of 1 plus tangent squared x dx. So I'll try to do the algebra a little bit ahead of time this time, so it's not as weird. What is 1 plus tangent as an identity? Ooh, excuse me.
This tan squared.
Yeah, 1 plus tan squared is equal to, you guys remember?
Secant squared.
Yeah, secant squared. It's gonna cancel the root, that's what we want, right? So we get 0 to pi over 4 secant. Now use a table to integrate this, otherwise you'd have to do yeah. Formula sheet says this will be ln of secant x plus tangent x plus from 0 to pi over 4. At that point, punch in your machine. That is about 0.88 something. That one wasn't too bad, right? Sometimes the algebra can get messy. Sometimes the algebra is really easy. Or sometimes you need to get clever on the substitution or a trig identity. But the theory and idea is not difficult. It's just trying to set it up or simplify it, I guess. It's a better word. Any questions on number 3?
We've heard of the other one.
Guess we'll stop here. That's pretty much it for 7.4. It's just going to be the same thing over and over again. You guys have any homework questions you want to do or any concerns or anything? That's it for the lecture today.
Okay.
I had a question about the testing. Did you ever get around asking see if we could get tested somewhere else?
I did talk to the chair. They said that officially the answer is probably no, but I would say do it anyway and just make sure you collect proof. So if they ever try to give you, any issues, you just say, well, here are all my proofs, so you're fine. So if we get tested somewhere else, I think it'd be okay. Hold on one second. This thing's freezing on me. One moment, please.